Welcome back, everyone. We've been learning a lot about similar triangles. Last lesson we learned about the mid-segment triangle. Today we are going to continue talking about parallel lines and the proportional parts with those parallel lines. First, you need to learn the triangle proportionality theorem. It says that if two or more parallel lines intersect two transversals, then they cut off the transversals proportionally. So for example, if you know that these three lines are parallel, AE, BF, and CG, and you see these two transversals, you'll know that these transversals are cut proportionally. So for example, AB over BC is equal to EF over FG. You should also know that the converse is true. If the transversals are cut proportionally, then you'll know that these lines must be parallel. Let's put this to work in an example. It says in triangle PQR, segment ST is parallel to segment RQ. We want to find PS. So let's set up our proportion. Since the lines are parallel, we know that the transversals PR and PQ must be cut proportionally. Therefore, PS over SR has to be the same ratio as PT over TQ. We'll go ahead and fill in the values now. So PS is what we're trying to find. We'll leave it as PS. But for the other values, we can substitute in what we were given. Now to solve a proportion, you cross multiply and divide. In this case, you should take 7.5 times 2.5, divide by 3. You'll get PS is 6.25. Go ahead and try the next example on your own. Here's the correct answer for this. Now let's try another. This is going to use the converse. It says that in triangle DEF, EH equals 3, HF equals 9, and DG is 1/3 the length of GF. Is segment DE parallel to segment GH? In order to answer this, we can find out if these transversals EF and DF are cut proportionally. So we know that DG is 1/3 the length of GF. Therefore, we could say that DG is X. That means GF would have to be 3X. You could also do GF is X and DG is 1/3 X. Either way will work. Now let's see if these are proportional. So let's try this transversal first. We'll do DG over GF and see what ratio this is. We have 1x over 3x. That can reduce to 1/3. Now let's check the other transversal. You have to make sure that you're using the same order. Since we used this piece of the parallel lines in between the parallel lines first, we'll have to use this piece EH first in the numerator. Now let's see, is 3 over 9 reducible? Yes, it reduces to 1/3. Therefore, these both have the same ratio. So that means that this proportion for the transversals is the same. So since these transversals are proportional, by the converse of triangle proportionality theorem, we can say yes, that DE must be parallel to GH. Now try the next one on your own. Here's the correct answer. These two do not have the same proportion, so they're not parallel. Now let's try this one. It says Megan is drawing a hallway in 1-point perspective. She uses the guidelines shown to draw 2 windows on the left wall. If segments AD, BC, WZ, and XY are all parallel, which I marked here, AB equals 8, DC equals 9, ZY equals 5, find WX. So what we can do for this one is we can say 8 over WX from the first transversal has to be equal to 9 over 5 from the other transversal. In order to solve, we cross multiply and divide. we get WX must be 4.4 centimeters. Remember, cross multiply 8 times 5, divide by 9. You should get 4.4. Since this one was given units, you must include units with your answer. All right, here's the answer for that practice problem. And finally, we have one more example to do together. This one says find x and y. On this one, you'll notice we have 3 parallel lines and we have 2 transversals. Now notice that on this transversal MQ, the transversal is cut so that they are congruent pieces. That means that the other transversal must also be cut into congruent pieces because it makes a 1-to-1 ratio. So since these are congruent, we can set them equal to one another. So in order to find x, we'll have to put 6x minus 5 equal to 4x plus 3. And in order to find y, we'll have to put 3y plus 8 equal to 5y minus 7. Now that you have the equations, you just need to use algebra to solve them. Subtract 4x on both sides, add 5 on both sides, then divide by 2 on both sides. You should get x equals 4. In the other equation, add 7 on both sides, subtract 3y on both sides, divide both sides by 2. You should get y is 7.5. Go ahead and try the 2 practice problems below. Here are the correct answers for these. Again, since the parallel lines are cutting so that one transversal is cut into congruent pieces, a 1-to-1 ratio, it means the other transversal must also be a 1-to-1 ratio congruent pieces. Same here, this transversal is cut into congruent pieces, meaning that this transversal also must be cut into congruent pieces, and we know that these lines are parallel because the corresponding angles are congruent. So with the parallel lines, we'll know if one transversal is cut to congruent pieces, all of them will be. Finally, let's think about this question. It says, write the converse of the following statement. Is it true or false? It says, if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. That's the statement we were just working with. I want you to see if you can come up with the converse and tell me, do you think that this is true or not? Why or why not? All right, that's all I have for you today. In our next lesson, we are going to be learning about the proportional relationships with corresponding segments of similar triangles. That's going to be such as angle bisectors, medians, altitudes. We'll talk about that more soon. I'm looking forward to it. Bye.